This is the DishyNOAC. This is from a company called Starvmount. The DishyNOAC is a DC power supply for Starlink specifically. They're made for the Generation 3 standard and the Generation 2 standard actuated. So this unit is actually compatible with both standard Starlink units. What this does is it takes the voltage from your battery system in your van or your travel trailer or your RV, and it steps it up to the required voltage for Starlink units. The input range is 9 to 36 volts. That means it's compatible with 12 volt and 24 volt power systems in your van or RV. And basically there's three connections here on this. You have the power input right here. You have the Starlink dish connection. That's where you'll plug in the Starlink cable to the dish. And then you have your router connection. So before we get too far into it, let's get a baseline of power usage here. So I've got my little portable power station here. This is hooked up to the router and the standard power supply through the AC cord here. So I'm using the inverter in this power station to power the Starlink dish. And I've got it connected and everything. I waited for it to boot up. I've got a YouTube video running here so that I'm on Wi-Fi and I'm using data. Let's just check out our power consumption here. This little meter right here is reading. Hopefully you can pick that up in the camera, but it's hovering about 60 watts, jumped up to 65 there, 68, 66. So it's right around that 65 to 70 watt range. So that's a pretty good baseline number. We'll compare using direct DC power using the DishyNOAC. So let's check out the power consumption. Okay, hopefully you can see this, but with the DishyNOAC, I'm hitting 53, 54, 60. Right now it's at 47, so 48, 60. So with the DishyNOAC, I keep calling it NOAC, but with the DishyNOAC, it looks like I'm running anywhere between 55 and 65 watts versus the 65 to 70 of the AC power directly. So you can see there is quite a bit of savings there. All right, so I've been watching it for a little bit just to see, you know, the average power usage from this, running it directly off of DC. So it seems like on AC, the dish uses around, let's just say 70 watts average. And when it's running directly off of DC, it uses around 60 watts average. And while 10 watts may not seem like a whole lot of savings, that's actually around 15% more efficient. Watts mean everything when you're off grid, when you're completely off grid, especially if you're relying just on solar. So if you could save 5 to 10 watts doing a DC conversion, that adds up in the long run. So that's why people do this. It's just much more efficient and much simpler setup, not having to worry about using inverters or anything like that.